Hey everyone and welcome to this session on PYQs. Here we are going to talk about surface areas and volumes. So let's begin straight away with the previous year questions from this particular chapter. This chapter is very important because you can see ample of questions are generally asked from this chapter. Here back to back in 2023 and 2024, two questions each of 1 mark were asked. Not only that, a 3 marker is also very important from this particular chapter. You can see almost appearing it is appearing every year, a 3 mark question, right? And you can also expect a long question of 4 marks. Even a 5 marker was asked before in the year 2021. So variety of questions you will find in this particular chapter, right? And entire chapter is formula oriented and calculations. We are going to see the problems. There you will also be able to recall all the formulae. Okay. So as you see, ample of questions previously are asked from this particular chapter. Variety of questions. You can also find 1 markers, 2 markers, 3 markers, 4 and also 5. So this year also you can expect any kind of question from this particular chapter. I still believe one MCQ sure shot might be asked, because if you see the pattern very carefully, two MCQs every year are asked, and it becomes very easy for them to ask MCQ based on surface area and volume. Directly formula oriented questions, you have to put the values and get the answer. And also expect a long question like a 4 marker or a 3 marker here. Anyways, let's continue. Let us see what type of questions were previously asked. So this was the first question asked in year 2020. Two cones have their heights in the ratio 1:3. So the heights of the cone is given. I can say ratio of the heights of the cone. So there are two cones. This is suppose the first cone and this is the second cone. One is bigger, one is smaller. So they are saying two cones are there and their heights are in ratio. So if the height of the first one is say h1 and the height of the second one is say h2, then it is given that h1 is to h2 is how much? 1:3. So the ratio of the heights are given and the ratio of the radii, that is the radius, that is also given. So if this is R1 and if this is R2, it is given R1 is to R2, that is 3:1. We are supposed to find out the ratio of their volumes. So tell me one thing, if R1 and H1 are the radius and the height of the first cylinder, R2 and H2 are the radius and the height of the second cylinder, then can I say the volume of the first cylinder V1 is equal to volume of the two cones, not cylinder, 1/3 pi R1 square H1, right? And the volume of the second cylinder is going to be volume of the second cone, not cylinder, 1/3 pi R2 square H2, correct? We are supposed to find out the ratios. Ratios means what? Just divide. So if I take V1 divided by V2, can I cancel 1/3? Yes. Can I cancel pi? Yes. So can I say V1 by V2 is equal to R1 square H1 by R2 square H2. So can I say here V1 by V2 is equal to R1 by R2 the whole square multiplied by H1 by H2. I am doing it like this because we already know the values there. What is H1 by H2? It is 1/3. So here I can put 1/3 and here R1 by R2 I can put 3/1. So this becomes 3/1 the whole square into 1/3. So that is equal to 9/1 into 1/3. So 3 ones are 3 threes are, that gives me 3/1. 3/1 is nothing but 3:1. So 3:1 is nothing but the ratio of their volumes. So 3:1 is the final answer. I hope this is clear. I've solved it in detail. If you're able to do it directly come to this step. V1 by V2, 1 by 3 pi gets cancelled, R1 by R2 the whole square, H1 by H2, put the values, get the answer immediately because it's a 1 marker, right? Okay, let's continue. So let's have a look at a new question. It says a cone of base radius 4 centimeters. See, we have to read the question very carefully, slowly, break it down and then solve. Okay, so cone of base radius 4 centimeter is divided into two parts. Okay, so there is a cone whose base radius is 4 centimeters. That is divided into two parts, right? By drawing a plane parallel through the midpoint of its height. Okay, if this is the entire height, so I can call this as h, right? H is the height. There is a plane which is drawn parallel to the base. So we are cutting it like this. So can I say it is going to be something like this? Such that this point over here is the midpoint, that is these two are equal. So height is divided by 2. So basically the upper part is h by 2. Correct? This part is h by 2. The entire height is h. I hope this is clear. Okay. And then compare the two volumes. See, whenever we are going to compare means take the ratios of two volumes. Take the ratio of two volumes, compare the volumes of two parts. That means what? We're supposed to compare the volumes of the upper part and the lower part. So upper part is ideally a cone, lower part is ideally a frustum, if you see. Okay. So a cone of base radius 4 centimeter is divided into two parts by drawing a plane parallel to the midpoint of its height. No problem. And then we are supposed to find out or compare the two parts. Now tell me one thing. If this is 4 centimeter, if I draw a line like this, and if I see the two triangles here, can I say the two triangles are going to be similar? Obviously, because this is perpendicular. So can I say this is 90 degrees, this is 90 degrees, and here is the common angle. Since the two triangles are similar, if this is 4, can I say this is going to be half of 4? So this part is going to be 2 centimeter. Why? Because see, the height is getting half, so radius will also get half. So can I say, if I talk about the volume of the entire cone, so if I talk about volume of big cone, can I say that is equal to 1 by 3 pi r square h. So can I say this is 1 by 3 pi. How much is r? R is 4. So into 4 square into h. H is h only, we don't know the height. So let's keep it h. So can I say this is nothing but 4 square is 16. 16 pi h by 3. This is what? This is the volume of the big cone. Now what will be the volume of small cone? Volume of small cone will be equal to 1 by 3 pi r square. R square is 2 square into h. Can I say h is nothing but h by 2 here? Correct? So that is equal to 1 by 3 pi into 4 into h by 2. So 2 ones are, 2 twos are. So that gives me 2 pi h by 3. I got the volume of the big cone. I got the volume of the small cone. What will be the volume of the remaining part? So can I say this part, frustum, is the remaining part? See, two parts, right? So the upper part is the actual part and the lower part is the frustum part. So volume of the remaining part. Volume of remaining part is equal to volume of big cone minus volume of small cone, correct? What is the volume of big cone? 16 pi h by 3 minus volume of small cone is 2 pi h by 3. So that is 14 pi h by 3. This is the volume of the remaining part, and that is exactly what we need to compare now. We are going to compare the volume of the cone with the volume of remaining part. So what we are going to do, volume of cone by volume of remaining part will be equal to, what is the volume of cone? The small cone, this one. We have 2 pi h by 3, the whole divided by 14 pi h by 3. How do we solve this? It's very simple. Pi gets cancelled, h gets cancelled, 3 gets cancelled. You get 2 divided by 14, and that is nothing but 1 by 7. So what is the comparison here? The comparison is that this remaining part is 7 times remaining part of the second part. The volume of the second part is 7 times the volume of the first part. That's it. That is the final answer. So we are supposed to compare the two parts. They can also tell you to compare the volumes of small cone and big cone. In that case, what you'll do? You'll take the big cone, you'll take the small cone, and you will divide. In that case, you'll get 2 by 16, that is 1 by 8. And 1 by 8 would be the final answer if they tell you to compare the two cones there. Correct? Perfect. Okay. So let's have a look at a new question now. It says, a bucket in the form of a frustum of a cone of height 30 centimeters with radii of its lower and upper ends, right? So there is a bucket. There is a bucket. Or you can say there is a frustum in the form of a bucket whose height is 30 centimeters. H. This is 30. And the smaller radius is 10. Upper radius is 20. That is also given in the question. So this upper is 20. The smaller is 10. Everything in centimeters. Find the capacity of the bucket. Also find the cost of milk which can completely fill the bucket at the rate of 40 rupees per liter. Okay, let's find out the capacity of the bucket. As of now, let's assume that the bucket is empty. So here, since the bucket is empty as of now, can I say capacity is the same as volume here? So we need to find out the volume of the bucket, right? Okay, let us do that. So here, can I say H is given, the height is 30, R1 is given, the radius is 10, the second radius R2 is given, that is 20, correct? So can I say volume is 1 by 3 pi h R1 square plus R2 square plus R1 R2. So that is equal to 1 by 3 into pi. Pi is 22 by 7 into h. H is how much? H is 30 into R1 square. R1 square is 10 square plus 20 square plus R1 into R2. R1 into R2, that is 10 into 20, correct? So this becomes 1 by 3 into 22 by 7 into 30 into 100 plus 400 plus 200, isn't it? So just solving this part. So this further becomes 1 by 3 into 22 by 7 into 30 into, see, 100 plus 400 is 500, 500 plus 200 is 700. So 7 ones are, this becomes 100, right? 3 ones are, 3 tens are. So this becomes 22,000 centimeter cube, correct? So 22,000 centimeter cube is the volume. Now we are also supposed to find out the capacity, right? So here the capacity of the bucket is 22,000 cubic centimeter. So we have already found out the capacity, which is 22,000 cubic centimeter. Now let's tackle this question to find the cost of milk which can completely fill the bucket at the rate of 40 rupees per liter. So at the rate of 40 rupees per liter, so what is the capacity of the bucket as of now? Capacity is 22,000 centimeter cube, correct? And if I divide this by 1000, I'll get the value in liters, isn't it? So I get the capacity as 22 liters. We are supposed to find out the cost of milk which can completely fill the bucket. Now see, the capacity that it can hold is 22 liters. What is the cost for 1 liter? The cost for 1 liter is rupees 40. Therefore, the total cost is going to be 40 into 22. 22 fours are 88. Rupees 880. I hope this is clear to all of you. Rupees 880 is the cost to fill the bucket at the rate of 40 rupees per liter. Perfect, easy question. So here is a new question. It says a solid metallic sphere of radius 10.5 centimeter is melted and recast into number of smaller cones. So there is a metallic sphere which is recasted into smaller cones. So how many cones we don't know. So small cones they are making, and some values are given. So a solid metallic sphere of radius 10.5 centimeter. Particular sphere has the radius how much? 10.5 centimeter, and the radius of each cone is 3.5. And okay, the height is also given. Radius is 3.5. The height is given as 3 centimeter. We're supposed to find out the number of cones formed. Okay, so whenever they tell you about melted and recasted, always remember this question is related to volume. So for that we need volume of sphere first. What will be the volume of sphere for radius 10.5 centimeter? Can I say the volume is going to be 4 by 3 pi r cube? That is, the volume of sphere is going to be 4 by 3 into pi into 10.5 into 10.5 into 10.5. Correct? Similarly, what will be the volume of cone? So can I say for cone, what is the radius? 3.5, is it? Yes, the radius is 3.5. then again h is 3. So what will be the volume of cone? The volume of cone is 1 by 3 pi r square h, that is 1 by 3 pi into 3.5 into 3.5 into 3. Correct? That is the volume of cone. Now we need to find out the number of cones. Number of cones will be equal to the volume of sphere divided by the volume of one cone, right? Volume of one cone. That is equal to, what is the volume of sphere? We have already calculated 4 by 3 pi. 4 by 3 pi 10.5 10.5 10.5 divided by one cone. Where is cone? Cone is here, 1 by 3 into pi into 3.5, correct, into 3.5 into 3. Okay, pi and pi is going to get cancelled. 3 and 3 is going to get cancelled. Correct? So this is 3.5, this is 10.5. 35 ones are, 35 threes are, 35 ones are, 35 threes are. Correct? 3 and 3 gets cancelled here. And then ultimately once you solve this, 4 threes are 12 and then you have 10.5, right? So here what do we have? Finally we get 4 into 3 into 10.5. So 4 threes are 12, 12 into 10.5. So that gives you 12 into 10.5. 10.5 multiplied by 12, 5 2s are 10, 2 zeros are 0, this is 1, 2 ones are 2, this is 0, this is 105, right? This is 0, 6, 2, 1, 126. That gives you 126 cones. So 126 cones can be formed with the help of the sphere. Correct? Let's continue further. So let's have a look at a new question now. It says, from a solid cylinder of height 30 centimeter and radius 7 centimeter, a conical cavity of height 24 centimeter and the same radius is hollowed out. Find out the total surface area of the remaining solid. Okay, so there is a solid cylinder. There is a solid cylinder. And some dimensions of the cylinder are given. Let us try to understand what is the dimension given of height 30 centimeter. Height of the cylinder is given. This height is 30 centimeter and the radius is 7 centimeter. The radius is also given, which is 7 centimeter. And a conical cavity of height 24 centimeter. See, this is 30 centimeter. Cavity of 24, that means smaller than this, is hollowed out and the radius is kept same. Okay, so the radius is kept same and a cone is hollowed like this. So this cone is removed. We are supposed to find out the total surface area of the remaining solid. See, what we will do is, if I remove this, the remaining solid will look something like this. This is just an example. Obviously, it's slightly difficult to imagine because this is gone. So inner part is still there. So obviously, it is going to look like this, but it will be hollow here, correct? And you can touch the cone inside. Firstly, we'll focus on the cylinder. Let's talk about cylinder. So for cylinder, what is given? The height is given. Height is 30. So I can write down h is 30 centimeter. What else is given? The radius is given. Radius is 7 centimeter. Correct? So what will be the total surface area of cylinder? Can I say the total surface area of cylinder will be 2 pi r h plus r, that is 2 into 22 by 7 into r is 7 into h is 30 plus r is 7. So this becomes 22 into 2 is how much? 44 into 30 plus 7, right? That gives you 37. So 37 and 44. So 7 for the 28, carry 2, 4 3 is a 12, 12 plus 2 is 14. So that gives you 1628, right? So 1628 centimeter square, okay. So that is total surface area of cylinder. So we have found out the total surface area of cylinder, which includes the upper circle, the lower circle. Now we will find out the total surface area of cone. So I can say for cone, the height is 24 if I am not wrong. Yes, the height is 24. Height is 24 centimeter. The radius remains the same, 7 centimeter. So what will be the total surface area? Can I say the total surface area will be 1 by 3 pi r square h, that is 1 by 3 into 22 by 7 into r square. R square is 7 into 7 into h. H is 24. So this 7 gets cancelled. 3 ones are 3 8s are correct. Then you get 22 into 56. Let us do that. So ultimately you get 1 2 3 2. So that is equal to 1 2 3 2 centimeter square. That is what, that is your total surface area of cone. Now what we did, we found out the total surface area of the cylinder, we found out the total surface area of cone, but definitely the cavity is removed from the bottom, right? If it is removed from the bottom, in both the cases, in cylinder also and in cone also, this circle is repeated twice. So can I say area of the circular base, area of or circular base or circle is pi r square, that is 22 by 7 into 7 into 7. This gets cancelled. So of course 7 to the 14, 4 carry 1, 7 to the 14 plus 1 is 15. So 154 centimeter square is the area of the circular base, but the circular base is repeating. So this gets repeated twice. So area of circular base into 2 will be equal to 154 into 2. 2 into 154, that is equal to 308 centimeter square. Correct? Now we need to find out the total surface area. So can I say the total surface area of the solid is equal to the total surface area of cylinder, which includes bottom circle plus total surface area of cone which also includes the bottom circle and then minus 2 times area of the circular base. So that is equal to total surface area of cylinder we got 1628 plus 1232, which is the total surface area of cone, and you subtract 2 times area of circle, that is 308, correct? That is equal to, let's solve this, 16281232, 3 plus 2 is 5 plus 1 is 6, 6 plus 2 is 8, 2860. So you get 2860 minus 308. So that gives you 2552 centimeters square, which is nothing but the total surface area of the remaining solid. So finally we got the total surface area of the remaining solid, and that is nothing but 2552 centimeters square. So the new question says water in a canal 8-meter wide and 6-meter deep is flowing with a speed of 12 km per hour. How much area will it irrigate in 1 hour if 0.05 meter of standing water is required? Okay. So water in a canal, see they are giving wide and deep. Wide is the breadth, deep is the height. So basically this is a cuboid. This is definitely not a pipe. That means it is not a cylinder. So there is a canal like this, and in this particular canal what they are saying is it is 6 meters deep. So it is 6 meters deep and it is 8 meters wide. So the width and the depth is given. So can I say for canal what is given? It is given that the height is 6 meters and this particular part, that is your breadth, you can say. Now let's talk about the length. They are saying that it is flowing with a speed of, so in this direction if I take, I need to find out the length, 12 km 1 hour. So if I take for 1 hour, the distance covered is 12 km, 12 km in 1 hour. So can I say the length will be equal to 12 km provided I take it for 1 hour. If I convert this in meters, it will be 12,000 meters, correct? So this is as per 1 hour. So let me find out the volume. So what will be the volume of canal? The volume of canal will be equal to L into B into H. This is for 1 hour. This is the volume for 1 hour, right? That is equal to 6 into 8 into 12,000. Correct? Meter cube. Okay. So in 1 hour, it is supposed to irrigate a land. So here, there is a rectangular land, you can say. So the water is coming on this particular land, and then if 0.05 meter of standing water is required, so basically the height over here is given. What is the height? The height is 0.05. Now this volume and this volume will be equal for 1 hour. The same water is going here. All we need to do is we need to find out how much area. Can I say length multiplied by breadth? This is the area and the height is already given. So can I say area multiplied by height over here is equal to the volume here? I can say the volume of canal in 1 hour is equal to the area irrigated multiplied by the height of the standing water. So here I get 6 into 8 into 12,000 is equal to, this is the area which we are supposed to find out, multiplied by 0.05. So let us take 0.05 down. So can I say area will be equal to 6 into 8 into 12,000 by 0.05. So this becomes 6 into 8 into 12, 6 into 8 into 12 into 1000. This is 1000 separate. I am making this as 5, correct, into 100, because 2 zeros I have considered there. So 5 ones are 5 20s are, correct. So all you need to do is multiply this. So 12 8s are 96, 96 into 2, correct. That is going to give you 192, and 192 into 6. So 1152, that gives you 1152, right? And then you have 3 zeros here, right? And that gives you the final answer. So that is your area irrigated. It is in meters, right? So meter cube. So this is the area irrigated by the canal over here. I hope you have understood this question. Easy? Perfect. Let's continue. So here is a 1 marker. It says the curved surface area of a cylinder of height 5 centimeter is 94.2 centimeter square, and the radius is given. We are supposed to find out. So okay, it's a simple question. Curved surface area is given. So there is a cylinder, and for this particular cylinder, what is given? The height is already given. The height is 5 centimeter, and the curved surface area is also given. We know that curved surface area is 2 pi RH. So 94.2 is equal to 2 into 22 by 7 into R into H. H is how much? H is 5. Okay, they are telling us to take the value of pi as 3.14. Correct. So curved surface area of cylinder 94.2. So 94.2 divided by, this becomes 5 into 2 into 3.14 is equal to R. So if I just remove the decimals, I get R is equal to 942 by 5 to the 10, and then this becomes 314 after removing the decimal. So this is 1s, this is 3s straight away. R is 3. Let us check. Yes, we have R as 3. So 3 centimeters is the correct answer. That means the radius of this particular cylinder is 3 centimeters. Perfect. So let's continue further. The new question says the curved surface area of cone having the height 24 centimeter and radius 7 centimeter. Simple question again. So there is a cone, right? We're supposed to find out the curved surface area provided the height is given. Okay, the height is how much? The height is 24 centimeter. The radius is given. Radius is how much? This radius is 7 centimeter. Height is 24, radius is 7. We are supposed to find out the curved surface area. See, what is the formula for curved surface area? The formula for curved surface area of a cone is pi RL, correct? So pi we already know is 22 by 7. Radius is 7. But do we know L? No. But can we find out L? We can find out L with the help of Pythagoras theorem. We know how to apply Pythagoras theorem. L square is equal to R square plus H square. 24 square plus 7 square. 24 square is 576. 7 square is 49. That gives you 625. Square root of 625 is 25. So L is 25. You put L as 25. 7 gets cancelled. So you have 22 into 25. Just multiply this. 25 2s are 50, this is 0, this is again 50, and you get 550. So yes, 550 is the correct answer, right? I hope this is clear to all of you. Simple question, straightforward, nothing much in this. Let's continue further. So the new question says an empty cone is of radius 3 centimeter and height 12 centimeter. Ice cream is filled in it so that the lower part of the cone, which is 1/6 of the volume of the cone, is unfilled, but a hemisphere is formed on the top. Find the volume of the ice cream. So ice cream looks like this. I'll give you the figure first. Correct. And this ice cream also falls down. So suppose it is up to this. And this is the empty part. This part is the empty part. And obviously here is the cone. And this part is also filled with ice cream. And the upper part of course is filled with ice cream. We're supposed to find out the volume of the ice cream. So to find out the volume of ice cream, what we are going to do, we'll find out volume of cone, volume of entire cone, can I say? Entire cone, that is this cone I am saying, minus volume of empty cone plus the volume of hemisphere. So first of all, what we will do is, we'll find out the volume of the entire cone. So the volume of entire cone will be equal to what? 1 by 3 pi r square h. So for this cone, what is the radius? The radius is 3. What is the height? The height is 12. That is equal to 1 by 3 into 3.14. The radius is 3. So 3 into 3 into h. H is how much? H is 12. This gets cancelled. So 12 3 is 36 into 3. So 113.04 centimeter square. That is the volume of the entire cone. Then volume of the empty part. It is already given that the empty part is 1/6. 1 by 6th of the volume of cone. That is equal to 1 by 6 multiplied by 113.04. That is 18.84 centimeter square. That is the volume of the empty part. So this empty part is 18.84. This cone is how much? That cone is 113.04. And then let's talk about volume of hemisphere. So volume of hemisphere is given by what? 2 by 3 pi r cube. That is 2 by 3 into 3.14 into r cube. R is how much? 3. So 3 into 3 into 3. This gets cancelled. 3 3s are 9. 9 to the 18, right? So 18 into 3.14. Isn't it? That is 56.52. Now let's find out the volume. So now can I say that the volume of ice cream will be equal to the volume of hemisphere, that is 56.52, plus the volume of the entire cone, that is 113.04. That gives you 169.56 minus the volume of the remaining, that is 18.84. That is 150.72 centimeter cube. That's it. Simple. So let's have a look at a new question. It says a solid sphere is cut into two hemispheres. The ratio of the surface area of the sphere to that of two hemispheres taken together is what? Okay. So see, a solid sphere is cut into two hemispheres, right? So after cutting this into two hemispheres, here the surface area of the sphere is going to be 4 pi r square, correct? And the surface area of the two hemispheres will be 2 pi r square plus pi r square, because it is a solid hemisphere. So definitely the base will also be covered. So the top one will also have the base, the bottom one will also have the face. So this becomes 3 pi r square, and this is for the first hemisphere, and also for the second hemisphere we'll have 3 pi r square. So if I add this, I get 6 pi r square. Now can I take the ratio? The ratio of the sphere, that is 4 pi r square, correct? 4 pi r square by 6 pi r square, that is 4 by 6, that is 2 by 3. So let us check if we have 2:3 in the options. Yes, 2:3 is the correct answer. Easy? Okay, let's continue. So the new question says the volume of the largest right circular cone that can be carved out from a solid cube of edge 2 centimeter is what? Okay, so there is a cube. Again, it's a one marker. Simple question. Let's solve. Let's not see the options. And then they're carving out a cube. They're carving out a cone from this particular cube. So definitely the cone will look something like this. If they want the longest one, it has to be like this, the circle, and then it goes like this. So can I say the height, the side and the height will be equal to the side of the cube? So can I say for cube, this side is 2 edge means side, right? So we are supposed to find out the volume of the largest right circular cone that can be carved out. So this side is equal to the diameter of cone. So can I say D will be equal to 2 centimeter? So can I say radius will be equal to 1 centimeter? Now radius is 1 centimeter and the height is 2 centimeter. So what will be the volume? Volume will be 1 by 3 pi r square h, right? So 1 by 3, then pi. Okay, are we having pi in the options? Okay, we have pi in the options. Let us keep pi as it is. Okay, let's see the options also, but let's keep pi because pi is already there in the options. No need to put 1 square. R square is 1 square. 1 square into h. H is 2. So that is equal to 2 by 3 pi. Okay, option D is the correct option, 2 by 3 pi. See, height will be 2 only. That is, height will match with the height of the cone and it will match with the height of the cube. Correct? But radius will become 1. Perfect. So let's have a look at a new question. It says, the difference between the outer and the inner radii of a hollow right circular cylinder of length 14 centimeter is 1 centimeter. If the volume of the metal used in making the cylinder is 176 centimeter cube, find the outer and the inner cylinder. Okay, radii of the cylinder. So basically, we have a cylinder. Correct? And then if you see, we have like this. This is a hollow cylinder. And if I take the two radii, say R1 and R2, suppose R1 is the bigger radius and R2 is the smaller radius, then the difference between the two radii is given, right? Difference means what? R1 minus R2 is given. So R1 minus R2 is already 1 centimeter given. The length means the height. So the height is already given. Height is equal to 14 centimeter. If the volume of the metal, so the volume of the remaining part, the volume is given, that is 176 centimeter cube. But can I say this volume is nothing but, okay, now let us find out the values. That is to find out the value of R1 and R2. So we know that volume of the metal, right? Volume of the metal is equal to volume of the outer cylinder minus volume of inner cylinder. So that is 176 is equal to, what is the volume of outer cylinder? That is pi R1 square H minus volume of inner cylinder is pi R2 square H, right? So can I say 176 is equal to pi H R1 square minus R2 square, that is equal to pi. Pi is 22 by 7 into H is the length, which is 14, and then you have R1 square minus R2 square, that is 176. So you get 176 into 7 divided by 22 into 14 is equal to R1 square minus R2 square, correct? So 22 ones are, 22 eights are, 7 ones are, 7 2s are, 2 1s are, 2 4s are. So ultimately we get R1 square minus R2 square is 4. Can we apply the identity here? Yes. A plus B, A minus B, that is R1 plus R2, R1 minus R2, that is equal to 4. But the difference is already given as 1. So can I say R1 plus R2 is 4. Now once I get R1 plus R2 is 4, I know that R1 plus R2 is 4 and R1 minus R2 is already 1, right? So once I add this, I get 2R1 is equal to 5, correct? So R1 will be equal to 5 divided by 2, that is 2.5, and once I put 2.5 over here, I get 2.5 minus R2 is equal to 1. So R2 will be equal to 2.5 minus 1, which is 1.5. So 1.5 centimeter is the final answer for R2, and for R1 it is 2.5 centimeters, right? So I hope you enjoyed this session alongside me on surface areas and volumes, a formula oriented chapter. You have to know the formula thoroughly, substitute the values, make sure that you don't make mistake in the calculation as well. See you again in the next session. Thanks for watching. Keep learning with top scholars.